Welcome to Engineers Academy. Subscribe to my channel and click on the bell icon to receive the notification for the upcoming videos. Now we are going to discuss this sample problem 213. So again, this is from the topic moment and couple, 3D moment and couple, right? So in this problem it is said that a tension T of magnitude 10 kN. So a magnitude 10 kN tension is applied to the cable attached to the top A. So this is the diagram, right? So this is the top point A, and the tension T of magnitude 10 kN is applied at this point A in this direction, right, from A to B, and of the rigid mast and secured to the ground at B. So we need to determine the moment about Z axis, right? So this is required. So we will find the moment about this Z axis of T passing through the base O, right? So this Z is passing through the base O, right? So we will find the moment about this Z, right? So first what we will do is that we will find the moment about this O, or I can say that first we will find the moment about this O Y axis, right? And then what we will do is that then we will use the dot product, and then we will find the component or the projection of that moment about O along Z, right? So this is the criteria. So now first what we will do is that this is the magnitude of T, right? So we know this. So first we will find the T vector, right? So what will be the T vector? So T vector will be equal to T magnitude and the unit vector, right? So to find the unit vector, what we will do, unit vector is always equal to AB vector divided by AB magnitude. So first what we will do, we will find the coordinates of point A and B from origin, and then we will find that AB vector and the magnitude of that AB. So if we want to find the coordinates of this point A, so we only need to travel 15 meters along positive Y, right? So there is no need to travel along X, along Y, and this is plus 15, right? And similarly, what are the coordinates of point B? So since this point B is in the XZ plane, right? Remember, sorry, this is the positive Y, so then this is plus 15, right? So I will write this is plus 15 and this is 0, right? So we need to travel only along Y. So since this point B is in the XZ plane, so what we will do, first we will travel 12 meters, this 12 meter along X, and then we will travel 9 meters along Z. So the Y component of this B, the Y coordinate of this B is 0, right? So I will write 12, 0 and 9. So these are the coordinates of point B. So now what will be that AB vector? So if I write, so AB vector will be equal to, so 12 minus 0. So 12 minus 0 is 12. So I will write 12 minus 0 I. Then I will write plus 0 minus 15 J and plus 9 minus 0 K. So again this is 12 I minus 15 J and plus 9 K, right? So this is that vector that already have written here in this the sample problem, solved sample problem, right? So 12I minus 15J plus 9K. And what will be the magnitude of this? So this is the magnitude, right? So 12 square plus minus 15 square plus 9 square under the root. And when we solve this, so we get this T vector, right? So this is T magnitude. So T magnitude multiplied by this unit vector. So this is that T vector. Now what we will do is that we will find the moment about O. So now, as we have discussed in the previous sample problem, that we have an open choice for selecting the moment arm. So it's upon us that whether we select which moment arm, right? So we can select this as a moment arm as well. So the definition of moment arm that I have already explained in the previous sample problem is that any vector starting from the axis of rotation to any point on the line of action of this force, so that will be moment arm, right? So in this case we can select this as a moment arm. Let me draw it, or let us consider this figure. So in this figure, this black arrow is the moment arm from O to A, right? So what will be that R vector? Let's suppose if I write that R vector, so that R vector is equal to, so if you want to find, so this is the origin, right? So the coordinates of origin are 0, 0 and 0, right? And the point A coordinates we already know. So this is 0, plus 15 and 0, right? So we can write this r vector. So what we will do, we can write it directly in these coordinates, right? So I will write 0i plus 15j plus 0k, right? So this is that vector, so I can write it simply. So it is 15j, right? So moment about O will be equal to, and this will be a vector, right? So moment about O will be r cross t vector, right? So r is 15j and cross, and it is 10 into 0.566i minus 0.707j plus 0.424k, right? So this is that t vector from here, right? So now if we take the cross product of this, so what we will do, we will write it in a determinant form. So I, j and k, and this will be 0, 15 and 0. This is the r vector, right? And here we will write, so if I multiply this, so it will be 10 into 0.566, so it will become 5.66, right? This will become minus 7.07, and this will become 4.24, right? So I will write 4.24, and this is the t vector, right? So now what we will do, we will use this first row to find the determinant, right? So I will write this, I will hide this, so we will take the determinant of this. So this will be plus 1 multiplied by the determinant, so it will be 15 into 4.24, and this is minus 0. If I multiply this, so it is 0, right? And then I will write I here as well, right? With j I will write minus 1, and I will hide this, so this will become 0, right? So 0 into 4.240, and this is 5.6 into 0, so this will be 0j, right? And then what I will do, I will hide this k, these elements, right? So this is 0, so I will hide this, so we will be left with this, right? So this will be 0 into this and minus this, right? So I will write minus 5.66 into 15k, right? So now this is the solution, right? So here it is written in this form, right? So it is 150 into this. So now if we take 150 common from this, so if I write 150, if we divide both of these and we take both of these by 150, and if we take 150 common, so then what we will be left, so here we will be left with 0.424i minus 0.566k, right? So we will be left with that same solution, right? So this is the moment about O, so I will write moment about O, right? So this is the moment about O. And now in the problem we are asked to find the moment about Z, right? So this is the moment about O, and as we can see that the moment about O has two components. So one component is along the x-axis, the positive x-axis, this is positive, right? And this is negative. So we can draw that moment in this diagram as well, right? So the moment about Z will be in which plane? So this is x, this is along the x-axis, and this is along the z-axis. So this moment will be in the xz plane, right? So as we can see that this is the xz plane, right? So this is the moment about O, and if I draw the components of this moment, so this moment will be, this component will be along x, positive x, and the magnitude of this moment is equal to 150 into 0.424, right? So this is equal to 63.6, and it will be in kilonewton meter, right? So first let me write here, so it is in kilonewton meter, right? So this component is 63.6 I and kilonewton meter, right? And similarly, if I draw another component, so this will be the along the z in the negative direction, right? So as we have seen here that this is negative, right? So this is that component, and its magnitude will be 84.9 k, and this is the direction, right? So this is the moment about O. Now we need to determine the moment about Z. So as we can see that we can use the dot product, right? If we want to find the projection of this moment on this Z axis, so what we will do, we will use that same concept, right? So the moment about Z will be equal to moment about O dot the unit vector along this z-axis, right? So I can write it like this. I can write OZ, right? So we will determine this OZ vector. So what is this OZ vector? So we can only write the direction cosines of this OZ vector. So what is that OZ vector? So this means that this OZ vector is in the k direction, right? So we can write that mz will be equal to mo dot k, right? So as we can see, right? So this is mz is mo dot k. We need to determine the projection of this mo along the z-axis. So the direction cosine or the direction of that z-axis or the direction vector of that z-axis is k, right? So what I will do, I will multiply the vector of this mo. I will take the dot product of this mo with k. So then we will find the projection of that mo along z, right? So we can do it. So what we will do, if we take this vector and this is the dot product with k, so we will be left with only the k term, right? So we will multiply this with this, right? So 150 into minus 0.566, so this is equal to minus 84.9, right? So this is minus 84.9. So 150 into this is minus 84.9 into k. So k dot k is 1, right? So we will be left with this. So it is minus 84.9 kilonewton, and this is minus sign, right? So what does this minus sign mean? This means that the moment is clockwise, right? So the moment about z is clockwise like this. So this is the moment about z, and its magnitude is 84.9 kilonewton meter. Right, so I hope you people would have understood until this point. So it says that the minus sign indicates that the vector mz is in the negative z direction, right? So if we rotate our fingers in the clockwise direction, so our thumb will point out in the negative z direction, right? So this means that the moment about z is clockwise moment, right? So whenever we use the vector product, that is the cross product, so the minus sign will represent the clockwise moment and the plus sign will represent the counterclockwise moment. So remember. So this is the solution A. So this problem has 3 solutions, right? So we have discussed the first solution of this problem. One thing I should also tell you people that this moment O will always be perpendicular to the plane of the T and R, right? So if we draw this plane, so this is that R vector, right? This is that T vector, right? So if I combine this line, if I join this point O with this B, and if I join this A with B, right? So this AOB, so it's a plane, right? And this plane is, if I extend it like this, if I make it like this, if I draw another parallel line to this OB, right? And I draw another parallel line like this, so this is a plane, right? Let me draw it in some other color like this. So this is that OB, right? And now if I draw another line like this, and now if I draw a vertical line from this point B to here, right? So this is a plane. As we can see that this T and R are lying in this plane, right? So the resulting moment will always be perpendicular to this plane, right? So this moment about O is perpendicular to this plane, right? So we can see it like this, or we can say that this moment about O will always be perpendicular to R and F, both the vectors, right? So if this is R and this is T, so we can draw the moment like this as well. If I draw the moment, if I draw a moment vector on the top of this, and now if I move this to this point, right? So this moment will be perpendicular to this T vector as well, and this moment should be perpendicular to that R vector as well. So as we can see that this moment is perpendicular to R vector as well, and this moment about O is also perpendicular to the T vector as well, right? Now we can solve that same sample problem, right, by using this method as well, right? So what does this method say is that we can use the Vergnon's method as well, right? So if we resolve the force of magnitude 2 into its component, right? So this is the t vector that we have already discussed in this sample problem. Now if we resolve this t vector into its components, right? So as we can see, if I resolve this, so this is the t vector and this is the point B, right? And this t is making some angle with this xy plane. So this is xy plane and this is some theta, right? Let's suppose that this is beta. So this is making some angle, right? So if you want to find this component, so then this txy will be t cos of beta, right? So this txy will be the component of this t in the xy plane. And now if we know the angle with the x-axis is, right? If we know either of the angle, let's suppose if I know this angle, let's suppose if we know this angle, if this is theta, so then t of x will be txy cos of theta. We already know this, right, from previous topic. And ty will be txy sine of theta, right? So if we resolve this, and the z component, this will be the z component, or this will be the z component. Let me draw that z component here as well, right? So this is that z component. So this is tz, and tz will be the t sine of beta, right? So this is the tz component. So now as we can see that if we want to find the moment about z, right? So the moment about z, so this tz is parallel to that z-axis, so it will never produce the moment about z, right? So here it is said that since tz is parallel to the x-axis, so it can exert no moment about this axis, right? So the moment z is then due only due to txy, right? So txy is only producing the moment, right? So far we will not discuss this tx and ty. So far we can say if we consider only this tz component and this txy component, so tz component is parallel to the z-axis and txy component is in the xy plane, so only txy component is producing the moment. And if we look into this txy component from this direction, right, so we will have this diagram. So let me draw that diagram as well. So if I draw it here, so this will be that point O, this will be positive x-axis, this will be y, and here somewhere here will be point A. And let's suppose that this is the txy component, right? So as we can see, and the z-axis is from out of the screen, right? So if I draw, this is the z-axis, towards us is the z-axis, right, out from the screen. So now as we can see that this txy will produce clockwise moment about z, right? So this is that clockwise moment. So now we can find the perpendicular distance of this txy from this point O, or from the z-axis, right? So then we will be able to determine the moment of this txy, right? So if I write it like this, if we draw that perpendicular distance, so it will be like this. This will be that perpendicular distance, right? But first we need to determine this txy component, right? Now if we consider this triangle, let's suppose if this is P point, if we consider this A, P and B triangle, this A, P and B triangle, so this is a triangle, right? And here we have 90 degree, this is 90 degree, right? So this means that if T is the hypotenuse, so this is perpendicular and this is the base, and this is beta, right? So if you want to find beta, so then tan beta, so tan beta will be equal to perpendicular, so perpendicular distance is PB, right? And the base, so the base is AP. So PB is equal to 9 meters, so I can write 9 meters. And similarly the length of this AP, so we can find the length of this AP from this triangle, right? From this triangle, right? So what will be the length of this AP? So AP will be equal to this length is from this point to this point, this length is 12, which is written here, and this length, this is 15. So this is a right angle triangle, so we can use Pythagoras theorem. So this will be 12 square plus 15 square under the root, right? So if we take the tan inverse of 9 meters and this thing, right? So what we will get? We will get the angle is 25.04, right? Or we can use another method as well. We can write, as we know that Txy is equal to T cos of beta, right? So now if I apply cos of beta to this triangle, this A, P and B triangle, so what will be cos of beta? So cos of beta, so the base, right? So this is the base and divided by the hypotenuse, AP base divided by hypotenuse, so this AB, right? So we can write it like this as well. So AP divided by AB. So now what is the length of AP? So AP is again 12 square plus 15 square. So we can write 12 square plus 15 square under the root 2. But what will be the AB square, right? So since it's a 3D vector, so we will take the square of all the three components of this T, right? So we can write it like this. So if we consider this triangle, this A, P and B triangle, so what will be this, the magnitude of this T? So it will be equal to Txy square plus this 9 meter square, right? So I will write 9 meter square under the root. So this is again Txy, right? So we can write cos of beta. This will be 12 square plus 15 square under the root. And this, if I put this again, so this thing is Txy, right? Remember, this is Txy. So we can write 12 square plus 15 square under the root and square, right? So this will be cancelled. So we will only be left with 12 square plus 15 square plus 9 square under the root, right? So this is cos of beta is equal to 12 square plus 15 square under the root, and this will be again 12 square plus 15 square plus 9 square under the root, right? So this is 15. So in this problem they have used this second method that I have explained right now, right? So this is cos, they say that the cosine of angle between T and Txy is this thing, right? So 15 square plus 12 square under the root 2 divided by 15 square plus 12 square plus 9 square under the root, and this is 0.906, right? So this is the cos of theta, and since we know that Txy is T cos of theta, so this is cos of theta, so T magnitude is 10, so 10 multiplied by cos of theta value is equal to 9.06 kilonewton, right? So we can use both of these methods. So since we know beta as well, so we can find Txy as well. So again, if I use this beta, so then Txy will be equal to 10 cos of 25.04. So we will get that same answer, 9.06 kilonewton. You people can try it yourself, right? So now we know the magnitude of Txy, so it is 9.06 kilonewton. So now what we will do is that we will find this perpendicular distance between Txy and D, and once we know this distance, this D perpendicular distance, so we can find the moment about Z using this formula. So T D perpendicular distance into Txy, right? So to find this perpendicular distance of Txy from this O point, so we need to have this theta, right? So this theta. So then we will be able to find this D, right? And we know this OA distance. So what is that OA distance? So that OA distance is 15 meters, right? So I can write that this is 15 meters. And now if we know this theta, so then we will be able to find this D using this diagram. So then this D will be 15 sine of theta, right? So now first we need to determine this theta. Now if I extend this Txy, if I extend the line of action of this x, so we will reach which point? So we will reach this point P. So I can write that this is point P. So now we know this distance. So this OP distance from this 3D diagram is 12 meters. So I can write 12 meters, right? And since this is a 90 degree, so we can find this theta by using tan theta, right? We can use sine theta as well, right? So if I use sine theta for this triangle, APO triangle, this is this A, P and O triangle. So if we use sine theta, so then in this triangle, this AP is the hypotenuse, and this large triangle, this APO, right? So this is the hypotenuse, this AP, this is the base, and this is the perpendicular, this is theta. So this is base, right? So the side which is opposite to theta, or the angle, will always be perpendicular, right? So this is perpendicular, remember, right? So this D is 15 sine of theta. This is perpendicular and this is base, right? So base is 15 meters and the perpendicular is 12, right? So now if you want to find sine theta, so we can apply this. So, and what will be this AP length? If you want to find this AP length, so first let me apply sine theta to this triangle. So sine theta is perpendicular divided by hypotenuse. So perpendicular is OP. So we can write OP divided by hypotenuse. So hypotenuse is AP. AP, right? So OP is 12. And what is this AP length? So we will apply the Pythagoras theorem. So again, it will be 12 square, this 12 square plus 15 square under the root, right? So we can write it 12 square plus 15 square under the root. So, and since D is 15 sine of theta, and since this is sine of theta, so this is that sine of theta and this is that 15. So when we multiply 15 with this sine of theta, so we will get that perpendicular distance between the txy component and the point of rotation, that is the O, right? So now when we multiply this perpendicular distance with this txy, so we will get that same moment magnitude that we have already found in the previous method, right? So in the first method, so that was minus 84.5 kilonewton meter, right? So now we can observe from this figure that this txy will produce the clockwise moment. So here it is written that and is clockwise when weave in the xy plane, right? So when we weave this txy in the xy plane, this is the xy plane, so we can see that this txy is producing the clockwise moment, right? So I have already drawn that direction, right? So now this is the second solution of that same problem, right? Now if we use this third method, so in third method, if we consider the tx and ty components as well, right? So if we resolve this txy into tx component, so this will be the tx component, right? So if we see it from this direction, right? So this will be the tx component and this will be ty component, right? So let me draw it like this. So this will be the ty component. So now as we can see that this ty component is passing through this point O, right? So it will not produce any moment about this z axis as well, right? As this ty is passing through this point O, so it will never produce any moment about z. This tz is parallel to this z, we have already discussed this, so it will never produce any moment as well. So this is not producing any moment, this is not producing any moment. So only tx is producing the moment about this O, about z axis, right? So now as we can see that what is the perpendicular distance of this tx from this point O, so this is that perpendicular distance. So now we can write that moment about z is equal to tx into 15. We can write it like this. So now we will find the tx component, right? So what is the tx component? So here we have found this theta as well, right? So we have found this using this sine theta, and as we can see that this tx is the sine component. If I draw that component, let's suppose if this is that component. Now if we consider this triangle, right? So this is theta, so this is the base, so ty is the base, this is txy is the hypotenuse. So this green one component is the sine component of this txy, right? So I can write that tx is equal to txy sine of theta, right? So we have already found this sine of theta, right? So then what will be this tx tx, so it will be txy. So what is txy? So we have already found this, so it is 9.06, and if we multiply this with this sine of theta, right, so multiply this, so this will be 12 divided by 12 square plus 15 square under the root, so this will give us tx, right? And now if we multiply this tx with 15, so we will get that same moment, this moment, right? So let me try it. So now if we solve this, so again we get that same result, so it is 84.9 kilonewton meter, right? And as we can see from this diagram, if we look towards from this side, right, so now we can observe that this txy component is producing again the clockwise moment, so we can write that this moment is clockwise as well, right? So these are the three different methods of finding the moment above z, right? So we can use any of the methods.